Hi, this is Eric Keller from Otoy. In this video, we're going to talk about how to use displacement maps within Octane Shader networks in Octane for Maya. And we're actually going to start from ZBrush, and I'm going to take you through the process of the way that I create displacement maps and then how I integrate them into the shaders to get them to work correctly. And for the example for this video, I'll be using this character head that I sculpted in ZBrush. And we'll be rendering it in Octane. So let's start by going over to ZBrush. So here is the model of the head in ZBrush. And I'm going to turn on the solo button and just focus on the head itself. I'm not going to worry about the other parts of the model for the time being. So the way this head is set up, I have a number of subdivision levels, which is kind of a typical ZBrush workflow. So at subdivision level 1, I have about 4,386 polygons. And you can see if I turn on wireframes, kind of a typical head setup. I do have UV texture coordinates for this model. If I go down to UV map here in the tool palette, and I'm going to click morph UV, you can see it's going to flatten out the model. So this is kind of what the UVs look like. Kind of very typical setup. So let's turn off morph UV, but we do want to make sure that our head has UV texture coordinates, otherwise it won't be able to create a map for it. Now when I create displacement maps, I like to use the multi-map exporter, which is found in the Z plugin palette. So if you click on Z plugin, go down to multi-map exporter and expand it, you'll see this menu. I'm going to turn on displacement because that's the type of map I want to create. I'm not going to worry about these other ones, and I'll turn on export mesh. I'm also going to go down here to the map size and turn on 4096, so that's a 4K map, 4096 by 4096. Make sure flip V is turned on so that the texture is flipped vertically. ZBrush, for some reason, ZBrush's UVs are vertically flipped from almost every other 3D program out there. So you have to turn this on to make sure that your texture map is oriented correctly and that it will map to the surface correctly when rendering with Octane. And I'm turn on recalculate smooth UVs at highest subdivision level. That's not always necessary to turn on, but I'm going to turn it on in this case. And then here in the export options, we have the specific options for the displacement map. So I'm going to set this to subdivision level 1, which means that the texture map or the displacement map is going to be calculated by comparing this subdivision level 1 that has 4,386 polygons, with the highest subdivision level, which has 4.4 million polygons. So here's subdivision level 1, 4,000. If I go up to the highest, which is subdivision level 6 in this case for this model, I have 4.4 million polygons. So that is how the displacement map is calculated. And I will turn on a few other settings here. I'm going to turn on adaptive and smooth UV. Again, these are not always necessary. If you turn off adaptive, you can turn on or you can adjust the DP subpix slider, which basically is the accuracy of the subpixels. But I'll leave adaptive on and let the computer figure it out. The type of displacement map I'm going to create is a 3-channel 32-bit EXR. The most important setting is this mid setting right here. So I'm going to set mid to 0.5. So this is what our displacement map is going to end up looking like after we bake it from ZBrush. And since I've set the mid value to 0.5 or 0.5, what that means is that, if you take a look here, this is the area inside the mouth in the displacement map, and this is 0.5 or 50% gray. And any areas of the model that correspond to this shading, the vertices will not be displaced. They'll just stay where they are. Now for lighter areas of the model, areas where the values are greater than 0.5 or greater than 50% gray, light gray to white, the vertices of the model will be pushed out by Octane at render time. So like right here on this area of the lips is a good example. Darker areas, areas where the values, the pixel values here are less than 0.5 or less than 50% gray, meaning dark gray to black, the vertices are going to be pushed inwards. And this is the result you get when you set that mid value to 0.5. If you set the mid value to 0, which is a common practice, That means that areas that are black or 0 or 100% black will not be displaced. Positive values, anything above 0, will be displaced outwards, and negative values, any values below 0, will be pushed inwards. In my experience, Octane for Maya works best when you set the mid value to 0.5 to generate a map like this one, a grayscale map. And then I'm going to leave the other options at their default. I'll go down here to Mesh Export. I want to make sure that I'm going to export the subdivision level 1, or the lowest subdivision version of the model. I'm going to turn on quads so that it keeps everything as quads. I'll turn on merge to merge the UVs. And then I'm going to turn off group. This is the most important thing. If this button is on, then ZBrush is going to split up the model, the polygons, which can rearrange the point order, which can really mess up your model. Make sure that GRP is off whenever you export a mesh from ZBrush. And sometimes it's on by default, so double check that every single time you export a mesh. So with my settings created, I will choose Create All Maps. And now ZBrush is going to go through the process of calculating the displacement map and exporting it and saving it to disk. So once the displacement map is finished calculating, you'll see a message here that says that the total time it took to make the map is about 2 minutes and 52 seconds. So let's take a quick look at the map in Photoshop. So here's what the displacement map looks like in Photoshop, and you can see mostly it's gray. We do have areas that are lighter than gray, like around the lips here, and those are the parts that are going to push out. You can see on the eyebrows and around the eyelids. And then of course we also have parts that are darker than gray, like around here, around the edge of the nose and around the eyelids, and then parts of the lips and so on, and even down here. And those are going to kind of push the model inwards. And if we take a look at image mode, we can see that this is indeed a 32-bit channel image. So let's take a look at how we would actually hook this displacement map into an Octane Shader network in Octane for Maya. So I'm using Autodesk Maya 2016 for this part of the demonstration. So the first thing I need to do is bring in the model. So I'll choose File, Import, and find the model. And I'm importing it as an OBJ file. So OBJ, and let's zoom out. Here's the model. Let's take a quick look at the UVs. So I'll choose UV editor. Let's see, here we can see there's our UV texture coordinates. So let's go to Windows Rendering Hypershade to open up the Hypershade. And I'm going to go down here. Let's make sure that Octane is actually loaded. So I'll go to Settings, Preferences, Plugin Manager, and scroll down and find Octane. Here it is. Make sure that it's loaded. And once it's loaded, I could find the Octane materials right here in the list in Hypershade. So I'll choose Octane materials. Let's click on Octane Glossy Material to create a new glossy material. And actually what I'm going to do is let's clean the graph here, select that new glossy material up here, and choose Graph Input and Output Connections just to keep things nice and clean. And I can switch this over to Octane Viewer. So I'm going to select the model here and right click over the shader here in Hypershade and choose Assign Material to Viewpoint Selection, or you could just simply middle mouse button drag it on top of the surface. Either way, doesn't matter. And now it's applied. The next thing I want to do is set my geometry type for my model. So I'm going to select the model and go into the Shape tab. Let's actually give this a nicer name, like Head Geo, just to make things nice and short. I'll go into the channel box, and under the Shape node, I'm going to go down to Geometry Type. Let's set this to Movable Proxy. And I'm also going to go down to the Open Subdivision level and set this to 1. That means the model is subdivided 1 time. So another thing I like to do, which is not always necessary, but I like to do it anyways, is I'll select the model, Mesh Display, Soften Edge, just to soften up the edges so it doesn't look so faceted. Let's take a look at the shader here, and I'm going to lower the diffuse a little bit, bring up the specularity, and increase the roughness just enough so that the highlight is kind of spread out on the surface. And the next thing I want to do is go down to the displacement section here and click on this checker box next to displacement. And I want to connect an Octane displacement node to that connection. So we're not using any Maya shader nodes, it's all Octane shader nodes. So here we can see Octane displacement node is being connected to the displacement of the glossy shader. I'll select the displacement node, and I'm going to set the level of detail to 4096 by 4096 to match my model. And I'm going to click next to texture and click on Octane image texture. This brings up this dialog. So again, this is an Octane node, not a... So I'll go in the source images folder of the current project, and I'm going to select my generic head displacement map. It's the EXR file right here. This is what was exported from ZBrush, and I'll choose open. Now again, this is an Octane image node that's connected here to the displacement node, not a Maya image node. So Octane image, Octane displacement into Octane glossy. Let's go back to the displacement node settings here. Now we can see the image texture is connected right there. Level of detail is set to 4096 by 4096. The next and most important setting I need to set is this mid-level. So I'm going to set that to 0.5. And if you recall, when I was in ZBrush in the displacement map settings for the multi-map exporter plugin, I set mid-level to 0.5. So mid-level here in Octane, this value needs to match the value that you exported from ZBrush. And I'm going to set the height to 1. Let's move this off to the side. As you can see the preview here of the displacement. It's a little bit hard to judge whether or not that's going to work on our model because this is a shader sphere. But let's move this off to the side here. A couple other things I want to do really quickly. Let's add a Octane sun sky node so that we have some nice ambient lighting here. And let's actually set this to texture environment, but we'll set the texture to 0.5, so that'll be a gray color. Here's the environment node back down here, and let's quickly add a light, Octane light that is. Put it over here. I'm going to set the size to, like, let's see, 5, the power up to 200. Let's move it up just a little bit, maybe off to the side. So now we're ready to take a look at what this is going to look like in a render. So I'm going to go to Windows, Rendering Editors, Render View. Let's make doubly sure that we have the right renderer set. So let's choose Windows, Rendering Editors, Render Settings. And make sure that this is set to Octane Render. I'm going to turn on my graphics card under CUDA devices. And we can leave this a direct light for now. Let's set this down to like 2000. 2000 is probably good enough. And I'll set the GI mode to diffuse, which is a little bit nicer than ambient occlusion. And then I'm going to choose Render Snapshot Perspective and hit the IPR button. Let's do a couple things. Let's bring down the light a little bit closer to the model and maybe bring up the power to, like, let's say 600, just so we can see kind of reflections on the surface there. And then let's zoom in, take a look. And you can see that the displacement map is not just getting the larger details, but some of the smaller details like the bumps and that kind of stuff. But we're also getting artifacts. So you can see that there's some problems right here. Also, if we take a look right here, we get some issues. This to me looks like that we have our height set too high and it's kind of exaggerating the details a bit too much. So let's go back to the hypershade, select our displacement node, I have it selected here, and let's set the height to 0.5. And in my particular philosophy for displacement maps is that if it looks good, then it is good. So I just essentially tune the height until we get a result that I think is acceptable. So we still see a little bit of an issue right there and a little bit of an issue right there. So let's set this to 0.4, and I'm going to use that ear right there as kind of like my benchmark for if I can get rid of some of these artifacts that I know that I'm at a good level for the displacement. So now that we have the basics of the displacement map set up, what we'll do in the next video is we'll take a look at tuning the displacement map to kind of balance out the level of detail we want while reducing any artifacts in the model. And we'll also take a look at how to use a bump map in conjunction with a displacement map. So we'll take a look at that in the displacement map part 2 video.